Hello everyone. This video is all about hypothesis testing with two samples. In my previous video, it's all about hypothesis testing for one sample. So this one is for two samples. So the objective is to determine whether two samples are independent or dependent before we go into the formulation of the null and alternative hypotheses for two samples. We have a consideration on comparing two parameters from two different populations. In the previous chapter, chapter 7, or in my introductory video about hypothesis testing, it only refers to one parameter from one population. So sampling methods, we have independent samples, and then we have dependent samples. So the sample selected from one population is not related to the sample selected from the second population. So for example, you have two samples, sample 1 and sample 2. So sample 1 is coming from population 1. Sample 2 is also coming from another population, which we call population 2. So if we have two samples, it is assumed that we have two different populations also. So population 1, population 2, we have sample 1 and then sample 2. So sample 1 is taken from population 1, sample 2 is taken from population 2. And when we classify sample 1 and sample 2 as independent samples, we look at also into a consideration that population 1 and population 2 are different populations. When I say two different populations, the members of population 1 are totally different from the members of population 2. And the members of population 2 are totally different from the members of population 1. So when we take sample 1 from population 1 and sample 2 from population 2, so it is also assumed that the two samples, sample 1 and sample 2, are having different compositions in terms of the membership. So members of sample 1 are totally different from the members of sample 2. And members of sample 2 are different from the members of sample 1. So if that would be the case, we classify sample 1 and sample 2 as independent samples. In terms of dependent samples, some books are calling that one as paired or matched samples. So it can be dependent samples, paired samples, or matched samples. So by definition, each member of one sample corresponds to a member of the other sample. So having sample 1 and sample 2. So sample 1 and sample 2 have the same membership. For example, you give a pretest, and at the same time, towards the end of the experiment, you give a post-test. Or before the intervention, you give pretest. And after the intervention, you give a post-test. You have to take note that the pre-test and post-test are taken from the same person. So for example, Maria is part of the experiment and you give a pre-test and post-test. So Maria has a pre-test score and then Maria has also a post-test score. When we look at into the second member, for example, Joseph, Joseph is part of the experiment. So Joseph has a pre-test score and Joseph has also a post-test score. So looking into the composition of pre-test and post-test. So the pre-test scores and the post-test scores can be classified as sample 1 and sample 2 respectively. Sample 1 is composed of all the pre-test scores. Then sample 2 is composed of all the post-test scores. So, since they're actually in pairs, because all of the pre-test scores and all of the post-test scores can be paired and all of them are taken from the same individual, then we classify those samples as dependent samples or paired samples or matched samples. So, to be specific, as you see on the slide, we have an illustration of independent samples and then illustration of dependent samples. So for independent samples, we have sample 1 and then sample 2. Earlier, I mentioned that the membership of sample 1 and the membership of sample 2 are totally different. And in terms of the sizes, sample 1 size may be equal to the size of sample 2, but there might be a case also that sample size 1 is not equal to sample size 2, or it might be sample size 1 is equal to sample size 2. So the number of members of sample 1 and sample 2 may be the same or may be different. In terms of dependent samples, as you see in the diagram, we have sample 1 and sample 2. Whatever you see in sample 1 has a pair in sample 2. Then whatever you see in sample 2 has a corresponding pair in sample 1. And that when we look at into the total number of members of sample 1 and the total number of members of sample 2, they are actually the same. Sample 1 size is equal to sample 2 size because there must be a pairing between what you see in sample 1 and what you see in sample 2. So going back to the pre-test and post-test scores that I mentioned earlier, whatever pre-test that you have at the beginning has also a corresponding post-test at the end of the intervention. So if Maria has a pre-test, Maria has also a post-test. So there is a pairing of the pre-test and post-test of Maria. There is also a pairing of the pre-test and post-test of Joseph in the example that I presented earlier. Next is on specific examples about independent and dependent samples. So in example number 1, classify the pair of samples as independent or dependent samples. So we have sample 1, weights of 65 college students before their freshman year begins. Sample 2, weights of the same 65 college students after their freshman year. So the answer is they are classified as dependent samples because it is mentioned in there that we have college students before freshmen, and then we have the same college students after their freshman. So if you look at sample 1 and sample 2, the membership is the same, and we have a pairing of sample 1 and sample 2. So it is indicated in there. The samples can be paired with respect to each other. Next example is on sample 1, score of 38 adult males on psychological screening test for attention deficit hyperactivity disorder. Sample 2, scores for 50 adult females on psychological screening test for attention deficit hyperactivity disorder. So if you look at sample 1 and sample 2, the members of sample 1 is only 38 and the members of sample 2 is 50. So there is inequality of the sample sizes, which I mentioned earlier that sample 1 and sample 2 can be the same in terms of sizes or can be different in terms of sizes. And that the components, the membership components of sample 1 and sample 2 are totally different. So it is noted on this slide, independent samples. Not possible to form a pairing between the members of the samples. The sample sizes are different and the data represents scores for different individuals. So we look at into hypothesis testing for two samples, so whether the two samples are independent or dependent. In the video that I let you watch about introductory portion of hypothesis testing, the hypothesis, the null hypothesis, and the alternative hypothesis are actually coming only from one population. And since there is only one population, there is only one sample. But in this presentation, there are two different populations and you take samples from the two different populations. And we want to find out if there is a significant difference between sample 1 and sample 2. So, for example, there is what we call a claim on whether there is a difference or there is no difference between sample 1 and sample 2. Taking into this consideration as a statement of the problem, is there a significant difference between sample 1 and sample 2? So I repeat, is there a significant difference between sample 1 and sample 2? So if you're asked to formulate null hypothesis and then alternative hypothesis, your null hypothesis, which we normally symbolize as HO, there is no significant difference between sample 1 and sample 2. So I repeat, HO, or the null hypothesis, will be there is no significant difference between sample 1 and sample 2. Then we look at into the alternative hypothesis, which we normally represent as H8. And then that is stated as there is a significant difference between sample 1 and sample 2. So I repeat the scenario for emphasis. The claim is there a significant difference between sample 1 and sample 2? So our HO, or null hypothesis, there is no significant difference between sample 1 and sample 2. Our HA, or alternative hypothesis, there is a significant difference between sample 1 and sample 2. Another example, when you look up into two different populations, and then we look at into the samples from these two different populations, and we look at into relationship between the two samples. So we look at sample 1 and sample 2 and find out if there is a significant relationship between sample 1 and sample 2. So we consider our claim as, is there a significant relationship between sample 1 and sample 2? So our HO, or null hypothesis, there is no significant relationship between sample 1 and sample 2. I repeat, our HO, there is no significant relationship between sample 1 and sample 2. When we are going to formulate our HA, or alternative hypothesis, it is in this way. There is a significant relationship between sample 1 and sample 2. I repeat, HA, or the alternative hypothesis, there is a significant relationship between sample 1 and sample 2. Another example is on claiming that achievement in math and achievement in English have a relationship. And in our previous meeting, I told you that normally we have that relationship in a negative perspective. Whoever is good in math is not good in English. Whoever is good in English is never good in math. But there might be a case that someone is good in math and someone is good in English. It is also possible that someone is not good in math and then not good in English also. So it can be positive or negative. So if we look at a consideration about achievement in math and achievement in English, and the claim of the researcher is that, is there a significant relationship between achievement in math and achievement in English? So I repeat, is there a significant relationship between achievement in math and achievement in English? And you are asked to formulate HO and then HA. So HO, there is no significant relationship between achievement in math and achievement in English. I repeat, there is no significant relationship between achievement in math and achievement in English. And then our alternative hypothesis, or HA, HA, or alternative hypothesis, there is a significant relationship between achievement in math and achievement in English. I repeat, alternative hypothesis, or HA, there is a significant relationship between achievement in math and achievement in English. So those are the things that you are going to consider on how are you going to write hypothesis, either HO or HA. And then going back to the proposal that you are going to make in Ed 303. So we look up into that proposal, looking into the relationship between content competence and pedagogical competence. It is being asked there, is there a significant relationship between content competence and pedagogical competence? If you are going to state HO, you are going to say there is no significant relationship between content competence and pedagogical competence. Looking into the alternative hypothesis, there is a significant relationship between content competence and the pedagogical competence. So I repeat, the claim is there a significant relationship between content competence and pedagogical competence? Our HO or null hypothesis, there is no significant relationship between content competence and pedagogical competence. Our HA or alternative hypothesis, there is a significant relationship between content competence and the pedagogical competence. So you can actually look up into the different problem statements in your research proposal, and then you can actually think of the appropriate null hypothesis and then alternative hypothesis. So thank you very much and have a blessed day to everyone.